Hello. Firstly, before I start this video, I want to apologise to everyone because I always put my hand up and I say hi guys, and that's quite sexist, isn't it really? Because I should be saying hi guys and gals, because I know there's quite a lot of women that are into engineering and model making, etc, etc, and workshop projects. I mean, look at Quinn, Blondiacs, Emma's spare room machine shop or something. There's quite a lot of women, and I think back in the modelling world there was a woman, I can't remember her name, was it Betty or something, I don't know, but apparently she made the most amazing steam engines. So I do apologise guys. So hi guys and gals, and welcome along to part 7 of making this slightly larger than miniature hit and miss engine that I'm doing. This part is making the cast iron Cosworth, sorry not Cosworth, the cast iron piston rings, not quite to Cosworth standards. I thought I'd just throw that in, sorry guys. Gals. So I'm going to have a go at making some piston rings. I need 2 to go on this piston I've got, which is this little fella, which is complete, and you'll have seen if you've watched part 6. We've grooved these grooves to 1.6mm wide and 2mm deep. We've taken out the centre for the conrod to fit, which it now does. We've fitted a little end, and we've fitted 2 locating screws, although they're coming out, and I've ordered some proper pointy head Allen carbon steel screws that will go in there, because this gudgeon pin, I actually, if you saw the video part 6, I spotted them so that the grub screws will bite into them, so the actual gudgeon pin will be fixed solid in there. Okay, I'm harping on again, sorry. So we're making the piston rings that will fit in there. I'm going to leave a bit of slack on them because I was concerned that because I'd cut 2mm deep that they might snap when I try and stretch them over the piston. So I'm maybe going to make them a little bit shallower, maybe 1.9mm inside diameter, or 1.8 less than that inside diameter. We'll see how we go with it, but that's basically the plan. So without much further ado really, what I could say is that it's possible that this might go over 2 parts, and I know all it is 2 piston rings, but there's a lot of complicated things about piston rings. Well, they're the heart of the engine, aren't they? You know, you take a racing engine, the piston rings, without them it wouldn't run. They are the most important thing. You've got to make sure that they seal all the way around, and if any of you watch Mr. Crispin, you'll see he actually made some, and he actually showed his error, that when he stretched them and heat treated them, there was a slight bit of light shining through between the cylinder and the ring. So obviously there's all that to address and to make sure it's right, otherwise you've got no compression, and no compression, there's no big bang. So we've got quite a bit of work to do on them. It might go over 2 parts, probably will, but I'll try and make them short parts as opposed to 45 minutes or whatever, which become boring. You fall asleep, you wake up, make a cup of tea and go to bed, and you haven't seen my video. And it's I'd like you to see my video, because I put my heart into this. I've never built an engine before, and I'm really trying, and there's so much to do. I mean, I'm probably, I don't know, am I 20% into it? Maybe 20% if that. into it so far. There's so much more to do, but I'm looking forward to it, and I'm actually loving doing it too. So without further ado guys, we'll move over across onto the lathe, and we'll show you where we're starting with the piece of cast iron that we've got. Thank you for watching so far. Right, I'm going to make a start of these piston rings. So I've got to get this down to 1 inch. First job, face it off so I can get a centre in it. Right, got to get that down to 1 inch. Yeah, get that down to 1 inch, then take this out and bore it to 4 millimeters under 1 inch, because the piston rings want to be 2 millimeters thick. I'm going to try and just work from this end the best I can, simply because, as you've already seen, I'm doubtful as to whether I'm going to get the rings on without breaking them, in which case I'd have to make them thinner so they would be more springy, tensile, whatever the word is, springy. So yeah, I think I'll try and save as much of this as I can, because I do not believe I've got any more cast iron. So 1.6 milli thick plus 1.6 for parting, and what we're going to do is make 3 or 4 rings. 1.6, 3.2, 6.4. If I go in 10 mil, if I go to 10 mil, I'm going to be alright at that. I'll mark it up. No, I don't be skinny. When 15. Gearbox in. Right, I've taken exactly, that measured 1.441 inches, and I've taken exactly 1 full turn of my dial on my cross slide, which should be 100 thou, which would be 200 thou total takeoff. So we should now read 1.241, if I've got that correct. bang on. So it is very accurate, everything's perfect. It's it was me that were doubting myself, Mr. Doubtfire. So there's 241 thou to come off, so I need another 100 on scale. Slow this down a bit. Let's slow. Another one. Right across. Middle. Zero. .5 0.1 of a millimetre. Okay. Yeah, that were in brass, wasn't it? Let's give it a try. I didn't get a zero on that. Zero. That's one serious drill bit, is that? I don't know what make it is. Oh, it's a go ring, whatever that is. 17mm go ring. I'm suspicious that to buy that new I'd have to get a mortgage. across at an angle. And pull it straight and draw it out. Bang on 840 thou. 840 thou is 20.422. One ring. .76 0.16 over, so that should clean up. There'll be that to break off. Oh, it just falls off, look. So that shouldn't fit the piston. And it doesn't. Too tight. Should be the same diameter as the piston, which it is. So that wants cleaning up. I'm gonna make a little jig, I guess, to hold them. I think that's what most people do. That one's a right little bit thinner. Yeah, 1.60, so if you rub that down it'll be too thin. In fact, it actually nips in piston now. So that one's going to be no good. Bob it over there. Not taking much off. I think I'm going to have to make a little older, because I can't press enough. They're cutting into my finger, so I need to make a little older. That's 1.5mm deep that these will sit in, 1 inch. Something like that, I'd do it, wouldn't I? I could just turn the end of that. Or better still, just use that. Skim it down. I'll take that out till it fits. Another fixture. that. Pretty much bang on that.
Proud by 0.3 of a mil.
Piece of scrap. That should do it. Right, that's our redundant ring. Feel like it's touching. Maybe it's because I'm pressing on paper instead of a hard surface. Lovely. That one didn't take much, did it? Two done. Top groove. bottom. Yeah, all the way around. So doom and gloom to come. Doom and gloom to come yet, guys. We've got 3 rings. We've got one that's oversized, undersized. It ain't actually that bad, look. It ain't bad at all. I don't know why I called it a Grec. In fact, it wants some more off it. So that is okay. That ring is okay. I don't know why I said it won't. But I'll leave it there. So we've got 3 rings to work on tomorrow and see what we can do. So I've got to snap them. Now there's the thing, innit? How do you snap them? I've seen people put them in vice, get a pair of pliers and just wiggle them till they break. Don't like that idea. I've seen a guy on a steel plate who sits him on a steel plate. Do you know what I'm saying? I've seen a guy, I haven't got a clue where I've seen this, and he gets a super duper sharp chisel and he just whacks it with it laid flat and it just breaks. Then there's Mr. Crispin. I mean, Mr. Crispin ain't stupid, he's a clever guy, very clever guy, and he just files a little notch on the inside with a 3-cornered file. Now I have got loads of little diamond files, 3-cornered ones of all sorts, and I did like the idea, but then he made a fixture which means I'm going to start again. It'd have to be made out of steel because aluminium won't work, and he pushes it over it with a die and he presses down, and as he presses down it breaks the weakest link, which is where he's filed it, and it snaps. I must admit it did look to be logically probably the best way of doing it. So it's quite possible that we might be making another little fixture which will just be a piece of steel bar. I've got tons of scrap steel bar, and just put something like a, I don't know, 4 or 5 degree taper on it and slide them down, and then a piece of tube over the top just to push on them, and maybe just tap it or put it in a press and press it. I think Mr. Crispin actually used the little fly press he's got. I don't have a fly press, but I've got a 12-ton hydraulic one. I know it's a bit of an overkill, but if I go gently, I can't see any reason why we shouldn't be able to do it. Okay, I think that's enough for tonight, guys. It's after 10 o'clock at night and we've done pretty well. I've made piston rings so far. Hi guys and gals, so this is the end of part 7, Mark 1 I guess we would call it, or part 1 of 7 of making the cast iron piston rings. I decided to do it into 2 parts. Normally I would have thought probably 1 part would have done it, but no, I'm going to do it in 2 parts, and there's such a small item but so important that I believe that we need to do it in 2 parts. I'm going to publish this part tonight later on, so hopefully by Tuesday you'll get that. So where do we get to? You've seen the video, so obviously this is the epilogue, I guess. Our piston and 3 piston rings. We have a 4th that will fit, okay. They are very dinky, and tomorrow I'm going to heat treat them and hopefully we'll fit them to the piston. If all that goes wrong, then I'm sorry guys, but we're going to have to start all over again. and we're going to have to end up making a new piston with a much shallower groove. Now, Mr. Crispin, if you watch the video of him doing, it's a steam engine what he's doing. I'm doing a petrol engine, and a petrol engine has much more compression than a steam engine, because a steam engine you're looking at 100 psi, 120 at max, I guess, psi pushing on the piston. When a petrol engine fires, you could be talking about 4,000 psi, you know, quite a few thousand psi going bang when that thing explodes and fires it down the bore. Therefore, the piston rings are more important on an internal combustion engine than what they are on a steam engine. Obviously you get blow-by, and on a steam engine you don't want blow-by, but on an IC engine it's even more important, because the more blow-by you get, the more it starts to burn. What am I talking about? Steam. Going back to my working career before I retired, I was involved in everything electrical, because that's what my job was, but steam as well. Steam, nasty stuff. Steam will find a hole, it'll burn a hole in a piece of steel pipe with steam, and it'll find a route to escape. It's like it wants to get out of jail. So what am I talking about? With an IC engine, when this thing fires, the pressure is trying to escape down the piston rings, down the gap, across the internal diameter of the piston, and back out of the ring, and then into the second ring. And if you've got a third and a fourth, some of these big hit and miss engines from America, they have 5 piston rings. There's no oil scraper, forget oil, because they're a total loss oil system, and the drip oil, and that's something we've got to do yet. We've got to drill this so that oil will drip into the little end. I suppose I'm rabbiting on a lot, but we are going to do another part to this where we break the rings, we expand them, we heat treat them, and then we're going to try our best to fit them onto the piston. If they break, then I'm sorry guys, I failed, and I'm going to start all over again and make a much thinner ring. Although when you look at them, they're not that thick. These are 1.8, so I should try and get a close-up. They're 1.6 millimeter wide. They're exactly to the thou 1 inch diameter, to the thousandth of an inch, and in the internal diameter is 1.8 millimeters. I cut the piston at 2 millimeters, so there'll be a 0.1 wiggle. Don't matter at all. As Mr. Crispin showed when he did the one he did, he's got massive slop in them, because he cut these quite deep. I think they were 3.6 millimeter, and then he halved it, so they rattle about all over, but it don't matter. It don't matter. We'll see how we go, and I'm going to try my best to make them fit. If they don't, we're in deep nabunga. I'll leave them there. Okay guys, so thanks for watching this part 7, and look forward to watching part 7 Mark 2. No, they're not Cosworth, they're not Ferrari, they're not McLaren. Mind you, McLaren are rubbish anyway. If you want to talk about McLaren, go watch RE Performance. Rick is a great young guy. He rides British superbikes. I don't think he does a superbike. I think he runs Super Sport now with an R6. but he's good to watch, and he's a very clever lad actually. He's very young and very, very clever when it comes to building engines. I'm not. I'm trying, but I'm doing my best. Thanks guys, thumbs up, subscribe if you've never watched this channel before. Help me grow. We've got to grow this channel. It's not about the money, it's about the sport of milling machine, lathe, TIG welding, messing about with cars, anything. Okay guys, thanks a lot.